four items in the middle of this agenda, and these are functional areas or activities, definitive functions and things you can do with our solutions to help you manage a unified communications environment. But I'll start with a short introduction. Network Instruments has been around for over 20 years. I joined just over 8 years ago myself. Last year we were acquired by JDSU. We're fitting very nicely into that organization. One of the things that is driving our growth as a business is certainly unified communications and the challenges that that presents. So I hope I can give you some good information here. What I'm going to give just as a quick introduction is just an overview of our solutions with some product names here where they fit in. So any of you familiar with things like Observer Suite and Observer Expert, these are software systems that are part of what is now termed Observer Analyzer within this kind of cake of various blue boxes. So Analyzer sits there alongside the GigaStor. It's an appliance. I'll talk more about that. We also have probes. Really the data that we're talking about primarily here is packet data. I'll talk more about how you access that and where that comes from towards the end. And at the top of our solution is our newly enhanced reporting platform called Observer Apex. So let's get on with this then. Firstly then, how do you obtain visibility across disparate components? What we mean here is unified communications. For some people it may just be voice, there may also be video. You could have other elements like instant messaging, like you may integrate this with email in order to do calls via your email client. So there's various components that can be sitting in here, and what I'm going to start off with is just talking about a scenario we actually had here within our organization where we were trying to integrate two phone systems, and you know, we're talking about a Cisco system and a different platform, and they both have their own ways of talking to the rest of the platform. So you know, Cisco uses their skinny call control protocol. Other platforms may be using SIP or their own proprietary protocols. For the two things to talk together, they're actually using H.225 signaling. So that's part of the H.323 standard of protocols used in terms of real-time communications. And because this is an open standard, you know, this is well defined, and we really take the approach of being as vendor neutral as possible. So when you're using open standards and these kind of technologies to integrate different platforms together, then our solution can certainly help you get visibility of that. We saw on one side, call server was sending this setup message that you can see up here. This is a summary of what was in the packet. And then it was just getting an acknowledgement straight back. So that tells us the network was delivering this packet. It was being acknowledged. The ACK came back 146 milliseconds later. But this release complete message came back. And if we go into that, what the system was actually saying was that the user was busy, which wasn't actually true, but that information that we got from the packet data sitting between the two voice systems enabled us to troubleshoot the problem and fix the configuration and enable that all to work. So that's my first kind of discussion, little example on that. What I wanted to look at next was, and this is really going from a kind of micro level of looking at packet data and looking at a particular communication attempt on the network, up to a much more global kind of holistic macro view where we're taking lots of different elements from an entire service delivery architecture and combining those together into a single dashboard. So what you saw previously was me using the Observer interface to look at those packets and using a function called connection dynamics. What you see now on your screens is an example of the kind of dashboard report you can build. So this is looking at a number of elements. This is looking at my voice traffic and calculating a mean opinion score. It's looking also at my video traffic, and we have a separate MOS for that. That's not something that is generally standardized across the industry, but we've really taken some of the algorithms we use to look at the voice, and we've applied those to the video component as well in order to get some quality scoring on that. Based primarily on the jitter and the packet loss, and also the actual codecs being used themselves. Okay, so what you can also see here is we have some data applications. We have an email service. So we've got, we may have a few different components in there. We could be looking at the front-end communications, most likely based on HTTPS from client applications, or might be using MSRPC or a protocol like that to talk to the email server. We're looking at that on the network. We're also looking at back-end SMTP traffic, or possibly things like POP3 and IMAP. And we're looking at instant messaging itself, so looking at whatever communications that uses depending on the system. So those are applications using TCP. This is all using UDP, and we're looking at real-time protocol in order to calculate these metrics. Everything's green here. That's good. That's what we want to see. That means that our metrics are in line with the normal baseline values. So what we mean by baseline is we're looking at a sample. We're looking at a certain number of time intervals, similar to the interval of time that we're looking at on this report. And we're then averaging those in order to create an idea of what is normal on the network. And then we can understand when we deviate from those normal conditions. You can see some of these have got filters on as well. So the filtering is going to help us to build these views that you see here. We can filter on things like those application components I mentioned, and also things like the subnets of where your servers are located. So there's a lot of flexibility here to really customize this reporting platform around your infrastructure. A couple of the other things that we can see on here, we've actually got some more detailed information here. We're looking at the worst performing calls, both from a voice and video perspective, and we're also looking at the worst performing conversations. So we can take some quite detailed metrics going down to the level of individual calls and conversations, and we can include those on our dashboard in order to see at a glance if one of these goes yellow or red. Is there a particular set of calls that's being affected? We might also include in here things like information that's specifically based around the data sources. So again, that could be the subnets, it could be things like VLAN tags, but it could also be the physical capture and trending devices that are feeding this data up, or the probes in the terminology that we use here. What I wanted to do just very quickly is to show you the process of creating these. So if I go here into the, this is the Apex reporting library, I have a whole set of these things here called widgets. So this is a very easy to use reporting platform. These widget elements are easy to create. Some of the ones that we have down here are what was shown in that particular dashboard view there. So for example, the voice mean opinion score is basically a status icon. That's what we choose here. We can choose other types of widget like tables, graphs, pie charts, a thing called an application dependency map, which I talked about in yesterday's session, which is looking at discovering what servers are communicating with each other. So we can choose these components, we can put filters on, we can then select from what data fields we want that to track, and in this case it's looking at the mean opinion score for the audio streams as an average. Okay, so I'll talk more later about some of the drill downs we can do and how we can get more details when we come in to try and resolve issues here. Let's go back to the slides, and my next point of discussion here is going to look at correlating data in order to start getting into some of the root cause of issues that we may see. So first place I'm going to look at this, similar to the previous example, I'm going to go into the observer application. And I'm going to look here at some traffic that we have here, which has, if we just go into this view here, here is a call between two voice over IP endpoints. And on this call, one of the things we can see is that the mean opinion score for the audio is low. So if we're seeing that, it probably means we're seeing either high packet loss or high jitter, or possibly packet loss very condensed into a short time period, which we call burst. So we have a number of analytical metrics up here relating to this call as a whole, and then we have the individual components of that call, where we see the RTP audio, we see quality metrics using RTCP, and also the SIP for the setup of that call. So now we can see on a particular direction of this call, using these arrows over on the left here, we can see exactly which direction of the call was affected. In this case, it's affected by high packet loss. We can see here that the packet loss has reached 7%, which is indeed quite high. So what do we want to do next? I think what we want to do is really see how this was occurring over time, and we can run a thing called an analysis graph. So my analysis graph here is showing me for each direction of this call. So I've got a purple direction and a green. So these are the two streams going between the two phones. And for each of these, I'm looking at the bit rate and I'm looking at packet loss. So it's quite interesting here to see that the bit rate for this purple direction is fairly constant at just below 90 kilobits per second. That's what we expect to see for G711. And then it drops dramatically. And at that time, we can see that this is where the packet loss is occurring. So we can see that this direction of the call, this is the one where we saw the red status flag. The expert analysis was telling us there was a problem. We can go in and see exactly when that problem occurred. And then we can correlate this with perhaps some other statistics looking at load on that particular part of the network and understand why that was congested and why that was dropping, because we can see exactly when that occurred and what that pattern looked like. In the other direction, we can actually see the bit rate didn't really get going until partway through the call. And you do quite often see this with calls where maybe one direction of the audio doesn't even start up until some time later. But there's no packet loss associated with that. So that means that's not caused by network impairment. We are seeing sequence numbers. In fact, in this case, it's a slightly more complex situation with this direction of the call. This is the view called connection dynamics. So this is what I showed you earlier. We were looking at a particular interaction between two voice server platforms using H.323 signaling, H.225. Here we see SIP, here's the invite, we can see the response codes coming back from that, and then we see the acknowledgement of that setup process. Then the packet data starts, but in this direction here, it's very slow to get going. In this other direction, we can see there's actually some packets that have no sequence number, and therefore the analysis sees them out of order. They're actually being put onto the network with incorrect fields within that data, and this is clearly an actual codec issue or an endpoint issue rather than a network issue as such. So next example that I want to talk about of this is if I go back into my reporting. So what you should be able to see here on your screens are a number of graphs that are showing us some of these VoIP quality metrics over time. I believe it's taking a little while. I can see the system's taking a little while to sync. You're probably still seeing some green traffic lights, so let's just hang on a moment while that catches up. Okay, I think that's caught up. So what we're seeing here now is, and this could be one of our drill downs, this could be somewhere that we go within. When we first see a traffic light go yellow or red, we might want to then see how is that metric performing over time, and again compare that with baseline. So here I can see my mean opinion score is tracking baseline. My jitter throughout the day is tracking baseline, although overnight it seemed to be slightly higher. These are very low values, so we can expect a little bit of variation. But my packet loss was exceeding baseline significantly. Having said that, it's still very low. You might want to take two approaches here. You could combine these thresholds with absolute conditions to say I care about a certain percentage of packet loss, or you could take this more dynamic approach where you're comparing with a baseline condition. What I wanted to look at here was whether this correlates with my traffic load. I mentioned that idea on the previous example. I like to see correlations between quality metrics like packet loss and jitter and activity information. How much traffic have I got? Did I get a burst of a particular application at that same time period, which could have impacted from a network perspective? So here we see actually there's not really a correlation. The packet loss went up slightly, but the traffic rate was actually dropping down at that particular time period. What I want to talk about next is just kind of building on the idea of the usability of this system. So I showed you earlier how to adjust a widget, how we can go and create your own elements to look at your own infrastructure in a number of different ways. Once you've got those elements, all these widgets, these different components, whether they be tables, graphs, or these status icons that give you the traffic light indicators, then you can combine those into your dashboards. And that is a really intuitive process, because you basically just say, I want to build a dashboard. I'm going to have one table at the top and two graphs underneath. And then you really just, it's as simple as just dragging and dropping those elements into your dashboard, and then you save that and you make that available to your colleagues. You can put permissions around that so that you restrict that to certain groups, or you can make that more widely accessible. Okay, moving on then, let's go back to our list of different functions that we're talking about here. So that's a couple of different ideas of performing data correlations. We did that in the analytics, where we were correlating between the bit rate and the packet loss, and we were identifying whether the variation in the bit rate was due to a network impairment, i.e. dropping packets, or whether it was something coming from the endpoint itself. And then we also looked at the correlation between the packet loss and the utilization, the actual loading of the network. And these things can help us identify the root cause. Is it network? Is it the infrastructure itself? Once we've done this kind of reporting and we're starting to really understand the kind of trends in our voice and the unified communications environment, we're probably going to want to set up some automation so that we can be proactively notified about some of these things. So let's just explore some of the capabilities from that perspective. Back in my Observer console view here, what we have are the abilities to apply triggers and alarms at individual monitoring and observation points, i.e. probes on the network. So what we've got here is we've got one of these that's looking at SIP transactions. So this is looking deep into the signaling information, into that control plane data, to look at the request and response codes and to characterize those over time. Again, we can baseline those in the reporting, and then we can apply alerting based on seeing certain response codes or seeing certain levels of response time. So there's a few options in there. What I've also selected in here, you can see there's many other types of real-time alerting that can be set up. I've also wanted to just draw attention, there are many different voice alarm conditions that we can choose. So perhaps I'll also choose VoIP call MOS audio, because that's a very simple one. And I've also got a thing called a filter-based alarm in here. And a filter-based alarm is going to do a pattern match or some other kind of matching and send you a notification if it sees a certain type of packet. So let's have a look at what these are doing. My filter-based alarm is actually looking for RTP packets that are not receiving the correct QoS marking. So if we look at what that filter looks like, the Observer application has many different types of filter rule that you can apply. So, everything for as simple as an address-based filter, or some kind of pattern filter, or things filtering on ports, VLAN tags. You can see there's many of these, and I can build them up into a logic, so I can add different rules as OR conditions or AND conditions, and I can negate those as well. So a lot of power with this filtering. This one is looking for RTP. It's a protocol filter, so it knows what the RTP header structure looks like. RTP can use lots of different port numbers, so a port-based filter is not effective for RTP, and this is looking into the actual data structure itself. And then this other one here is looking at the type of service field. That is a field within the IP header. What we're looking for is the number 5. That could equate to 46 if you're using DSCP, Distributed Services Code Point. That will be a 46, but it will match on the first 3 bits of that, so that means it won't matter what the additional parameters within there are set to. So that will capture everything that is either 5 in terms of IP precedence or 46 in terms of DSCP. But what we're doing is we're actually catching everything that does not equal that value. So that's what I want it to be, but if it isn't, I want to be notified that I'm seeing packets that are not correctly marked. So that's how my filter is working. I've also got this, which is looking in real time at all the calls that are active, and if any go below, maybe I made the threshold a little bit lower, 3.5 or 3.7, something like that, to pick up when calls are deteriorating. And then in terms of the signaling, I perhaps want to look for any SIP errors, or I may want to look for a response time to my call servers that exceeds 50 milliseconds or 100 milliseconds or whatever I want to make that value. So I've got these 3 different conditions that I'm looking for, and then I'm going to apply some actions based on that. So my actions can be to send an email notification or to send an SNMP trap, as well as automated functions. If I have a GigaStor, I'm capturing all these packets already so that I can drill down to these details and look at the root cause and where this has come from. If I don't have that capability and I have just an observer probe, I could actually automate the process of doing the packet capture function itself, so that I capture the traffic that's generating these conditions, these notifications on the network. That's part of the story in terms of real-time notification. The other part, I'm going to go into the settings of Apex just to talk about the idea of an Apex alarm. So the benefit of alarming with Observer Apex compared to using the observer alarms I just showed you is twofold. Firstly, I can alarm based on aggregated data. So if I have lots of points of observation where I'm looking at the voice traffic across the network, Apex can take all those statistics, group them, centralize them into one place, and then process that information based on its thresholds. So what do I mean by the thresholds again? Just to remind you, I was talking right at the start about this dashboard, which is looking at voice and video and looking at response time for the email and the instant messaging. And all those parameters are being tracked in terms of deviation from baseline. Those deviations are set in terms of a percentage. So that percentage can be modified. You may want to have a very strict, sensitive deviation threshold. For example, just a couple of % of deviation and you might want to be notified, or you may want to be much more tolerant and only tell me if the deviation is maybe 60 or 100% or maybe more. So all that is configurable. There are default values which are usually very useful, but you can go and change those for your environment and for your requirements. So once you have that set up, that is your dashboard. You can see here when I create an alarm, first I choose a business group. That is the data source that I am going to, or the set of data sources that I'm going to put into the alarm notification. And then I choose the dashboard, which is going to be one of my dashboards that has these status icons that are looking at threshold information, or it could be a threshold-based graph that you saw earlier as well. The other thing I can do is put filters around that, and I can also do that on my individual threshold settings. So let's just have a look at what I mean by that. If I go into this area called thresholds, and we focus this specifically on a voice-related parameter, let's actually choose jitter. So jitter is set to send an alert. In fact, let's look at this in terms of the baseline value. So if the jitter exceeds 60% above baseline, then it will be a yellow traffic light or a marginal degradation condition. If it exceeds 120%, that will be red. I can also configure that so that maybe I look at certain infrastructure as being more critical. This may make more sense from the perspective of a data application like your email access. You could choose response time here, and then you could say that's quite a critical service, perhaps, and set those thresholds appropriately. So with the alerting from Apex, I mentioned there are two benefits compared to the alerting from Observer. There's the aggregation, and then there's also the ability to set the thresholds based on a deviation from a baseline rather than an absolute performance value. Okay, so moving on here and just checking briefly for questions. So let's go back to the PowerPoint information. What have we got here? We looked at the threshold-based automation. So my final area that I'm going to talk about in terms of a functional activity to perform is really finding that one call that had a problem out of what can potentially be hundreds of terabytes of data. We all know that networks are getting more and more loaded. The data volumes are escalating tremendously. We can capture on a single GigaStor up to a petabyte of packet data. That data is going to have potentially thousands of calls within it and all those other applications that you may be feeding into your point of observation. So how do you find that one call that had a problem? Let's go through some ways of looking at this. So I'm going to go into my Observer console again. In fact, I'm going to go to this remote system over here where I have my GigaStor and just explain this interface. So this is how we can deal with those potentially hundreds of terabytes of capture data. We have this interface where we can go to the time period where the problem occurred. Perhaps we have a ticket. Perhaps we know that we need to go back to April the 21st at 2 o'clock in the afternoon. We can do that, and then we can start to look at that specific time. Perhaps we need to use the reporting first. So in this way, we can go to some of our dashboard views that we have here. I think this one might be one of the ways in which we could use it. This dashboard is actually looking at the SIP transaction codes. So maybe we see some kind of problem. Perhaps we've used this to set our alerting, and then before we get notified and we know what time we need to go to see that perhaps there were some SIP errors occurring on the network, which could be causing voice problems. Perhaps we go back to our dashboard that we saw earlier, where we are looking at the individual voice calls, and we get the time of call, and we can drill that down into that using some integration between our web report and the GigaStor data mining interface, which I'm going to show you. So there's a number of ways in which we can correlate and get the information we need to then drill into that data. One of the things we can do when we click this Analyze button, we have a number of filtering options. So I was talking about filtering earlier. We can use the filter based to generate an alarm. or we can use our filtering to retrieve certain packets. If we generate an alarm with the filter, then obviously when we apply the same filter within data mining, we're going to get the same packets that generated the alarm. So it's a very consistent interface in terms of how you use these core functions. We have an option here called VoIP and video conferencing calls by SIP tag. This allows us to, for example, filter based on the dialed number. That's not as straightforward as it may sound. If we were to apply that as a pattern filter, that would give us the SIP invite packet for that call, but it wouldn't give us all the detail, all the actual audio streams, because they don't include that dialed number within them. So what this option does is it's going to do all that processing for us. It's going to look at that invite packet, and it's going to work out what are all the audio streams that were set up for that, and let's retrieve all of those. So it's going to do a kind of multi-iteration of processing to pull back that call data for us. So this is saving a lot of time when I want to retrieve a call. Voice can be quite a complex environment due to all the different components within that. So this has now retrieved the call based on this dialed number. There's actually a couple of different RTP streams that were initiated. The MOS is low, so I can now start to get into the analytics, looking into this just as I was showing you earlier, using these expert analysis functions. You can see here my expert analysis summary is telling me that the jitter is high for this call, so I can start again to look at correlating that with the network activity at this particular time, and understand where that has come from. Incidentally, the expert thresholds here include quite a lot of voice-related expert conditions. So this really works in parallel with the real-time alerting that I showed you. You can see here how much capability there is to look at both voice and video traffic alongside the data applications that are well supported within the observer application. Okay, so let's look at maybe one more thing within this. The last thing I wanted to kind of look at here is a function called multi-hop analysis. This really sits on its own within our solution, but this again is another benefit of the capture data, is that you can look at the latency in a very granular way with this kind of view. So that can be particularly important for voice traffic. Voice traffic is obviously very latency sensitive, as is video. If the packets are delivered too late, then they may as well have not been delivered at all. So this is looking here at how voice traffic was delivered across a firewall. That's a very likely area where you may have latency issues that could be affecting the streaming of some voice data. So we've captured on either side of the firewall, on the outside where the packets are then coming in. This is a one-way stream of audio traffic that we're seeing here. So we see this packet, and it was on this outside, the kind of dirty side of the firewall, and then we see it here about 30 microseconds later on the inside of the firewall. This timestamping is very reliable because it's all going into a single GigaStor across multiple capture ports, which have a single clocking on them. So this is very useful information to understand what does the firewall do. We can present this maybe as evidence to a vendor to say, this is what your firewall is doing to our voice. Can we configure it? Maybe the latency is varying a lot, which we don't want. If we're getting jitter, we can see how that is affecting these different packets over time. We get a summary of that, so we can see what is the maximum and the average and the minimum delay times as well. And that really gives us a good idea of the network impairment, where specifically on the network is that happening. We could load in up to 10 different trace files into this system. They don't have to be captured within the observer application. We can take data that's captured, for example, with Wireshark, and we can load that into here as well. We just have to convert it into the observer format first. So what I've done there is really talked about, the GigaStor is how we can locate that call within a huge volume of data. The GigaStor control panel has its own reporting on, so we can look at, can we see the host that we're interested in? Can we see those IP conversation pairs associated, whether that's with the voice elements and the video elements, or it could be the other parts of unified communications that are using TCP, such as your integration with email and with things like instant messaging. So we have all those elements. One thing that I wanted to just go back and show quickly before I wrap this up is there's kind of a special case that we can deal with as well. If anyone has Microsoft Link, then they may be aware of the fact that Microsoft Link encrypts the signaling traffic. So it's using SIP, but it's actually running over SSL. That means that we can't see that signaling within our voice expert analytics, but we can actually provide some additional processing on that. So if you are managing your own link infrastructure, then you will have access to the private key file used to generate that encryption. And if you have access to that, that may be, in this case, I'm just going to browse to it on my desktop in a more secure environment. This was actually captured in a test environment, but we can also use hardware security modules, so we can integrate with the way that manages these encryption key files in line with the Federal Information Processing Standards from the United States. But anyway, so we can manage those keys for you, but we can then process those. We can then use those to decrypt the call, and now I have the signaling visible, and I can go in and do the analytics, see that there was a negotiate request and then an OK message for this particular call. And we can do that in real time on the trending data that's then feeding up to that reporting interface, where we're then going and looking at things like the SIP transactions that we were looking at earlier, tracking these response codes, seeing if we're getting errors within the signaling layer itself. Okay, so what I want to get to next is really kind of back into the slides here, and let's talk a little bit about how we would then implement this kind of technology. The thing I like about this diagram is the reference to the East Coast and West Coast. You can all guess that this has come from a US environment, but I like to imagine West Coast as perhaps being Aberystwyth and East Coast as being Scarborough. So after localizing that, what this is basically just showing is two networks connected over a WAN, and this is describing a couple of ways in which we can potentially monitor that. So what we have here is first option, we're really looking into the access layer. So this would be a scenario where your analyzer, your probe, your GigaStor is receiving span data from your access switch, which is spanning out all of your IP phone ports, perhaps your entire voice VLAN. What you're then getting visibility of is basically all the traffic from those phones. What you're not seeing is any traffic from any remote site to your local call manager. That's hidden from your analyzer. But if you were doing the same thing at this remote site over here, then you would see that traffic going out to the remote call manager. So that's one way of looking at things. I guess the drawbacks to that are you may just have too many access switches to do that, and there could be other potential issues from trying to span out that VLAN. You'd have to look at whether that's supported, whether that's going to work well in your environment. So a few things to think about there, but that is an option, and certainly some customers do go down that path. The other way of looking at voice would be this approach of looking at the signaling and then the traffic going off net or off site or over the wide area. So in this case, what we're doing is we've got, again, this switch. This time we have a span session which is copying the traffic that's going to the call manager here, and also the traffic that's going over this uplink from this core switch going out of the site to the WAN. So by doing this, we're now getting visibility of any traffic from these phones going to the call manager, so we're able to see all that signaling data, and we are also seeing the RTP audio or video flows going from this network over this core switch or switches over the wide area, or possibly to a PSTN gateway. That would be another way of looking at it. What we're now losing visibility of is the traffic going between these phone systems, but it may be that we might make an assumption, or we might have perhaps evidence to suggest that that is perhaps not where the audio problems are most likely to occur. Another way of thinking about this, if you have a problem talking to the guy in the same office, maybe you can just go around and talk to them, but maybe that's a bit old school. So those are kind of a couple of options around how we look at voice data, and there's a few different ways to think about that, but that's certainly a discussion to have. Back in the data center, this is where we may have additional voice infrastructure. There we were looking at, I guess, branch sites or maybe administrative locations where we have a lot of end users. Here we may be looking at maybe some managed services that we're delivering, and so everything's coming into this location remotely, or this may be an enterprise deployment where we're now concentrating on the gateway to the PSTN or the signaling infrastructure, or those other services that we're talking about in terms of unified comms, the email, the integration with those other systems, the instant messaging, etc. So typically our GigaStor appliances very often sit between the core infrastructure and the server switches, or between the server infrastructure between the LAN and then the WAN distribution layer. Both of those have some pros and cons. This example hooks in with the multi-hop that we were looking at. This is how we'd actually get visibility to look at the traffic traversing the firewall infrastructure by having a tap either side of that and feeding that in. So we're showing this with taps here for this GigaStor and for this one. That's a very good way of monitoring because of the level of passiveness or passivity, let's say. It's very passive. We're not having to configure anything on the network, and it's very reliable and very accurate. But we can still use spam ports to feed into the GigaStor here, and that's what we seem to be doing for this distribution and these access layers. So all these options are possible. This is where things like budget and cost are very much going to come into the discussions around a potential solution. Just kind of rolling that up one level just to see how these components that I've talked about here are interacting with each other. I've talked about the GigaStor when we went and did the data mining operation, when we put in the phone number and then we extracted the data from the packets stored on the GigaStor. This is what I was talking about with this GigaStor component. When we're looking at the network trending is the process that's providing statistics for the web reporting that we looked at with the dashboard views. That could come from a GigaStor or another type of probe. And so that's sending statistics up to Observer Apex, which we are accessing with the web browser, but we're using the Observer console to access the GigaStor and probe licenses. So Observer Suite would sit over here as a way of accessing a GigaStor, but could also be a type of probe in itself because it has its own local probe. So it's a very flexible type of environment to do all kinds of different things with in different scenarios. Okay, this is types of GigaStor solution, really ranging in terms of the port density and the types of ports supported. They all support 1 and 10 gig, up to 12 ports for most of the larger systems, and they range from 4 terabytes to a petabyte of data, as I said earlier. And really now we're back to my my summary. So what I've taken you through there is some specific activities, some particular functions in terms of unified communications performance management from a network perspective. We've looked at the visibility across multi-vendor environments. We looked at that in terms of combining dashboards in Apex. We looked at that in terms of the packet view, giving you a kind of neutral perspective to troubleshoot integration issues. We then went and looked at some other correlations that you can do, both here within the Observer Analyzer. That data could come from a GigaStor, it could come from Observer Probes. And we also looked at correlation of data within the reporting view to get those more long-term trended visibilities of the information. Then we went and talked about automation, both of alerting within Apex here and also within the Observer and on the GigaStor itself, and on Probes they can also do that alerting function to notify you. And then we looked at the data mining operation, finding the call. The GigaStor has an interface that allows you to quickly go find that proverbial needle in a haystack. So I hope that's been useful, and please speak up with any questions. I'll hand back at this moment.